Hey math kids, today we're going to talk about piecewise functions, and we're on assignment 2.BA. So I'm not too concerned with you graphing this stuff by hand, but I want to just I don't even care about you graphing it by hand, so let's just do this with a calculator. Now you can use any calculator that you want to. You can use a handheld graphing calculator, you can use like Desmos, whatever you feel most comfortable with. And I'm just going to write this example problem down. I will talk about how to do this by hand, but I will also talk about how to do it on a calculator. So if I was going to do this by hand, I would draw my axes and then graph each of these as if they were by themselves. So x plus 2, that's like y equals mx plus b. So I start at 2 on the x-axis, do a dot, then the slope is 1 over 1, so I go up 1, over 1, and then I connect the dots. Okay. Now if I'm drawing the other one, this is a parabola that would cross at the origin, but since it has this minus 3, we actually go down 3 and draw a parabola. So step 1, when we're graphing piecewise functions, just graph each piece as if it was the only thing there. Now we need to look at the domain restrictions for each piece. So I've got that in yellow. Let's see, let's do orange. That yellow, I don't like that yellow. Okay, and see how the transition point is at 1. Both of these are, one is less than or equal to 1 and one is greater than 1. And so our transition point is going to be x equals 1. That's where we switch from one to the other. Now if we look at the blue function right here, it says only draw this when we are less than or equal to 1. So less than would be to the left, or equal to right there. So I'm going to get rid of the blue one from there to there. Now we want to look at this symbol. Since it's less than or equal to, the point where we transition is going to be a filled in dot. So I'm going to just trace back over this, and it looks like that. Okay, now we look at the pink one, and the pink one is only drawn greater than 1. And so this line that's at 1, anything that's less than that I don't want to draw. So erase it, and it looks like that. Now the transition point does not have a line under it, it is not equal to, and so when we draw the transition point, it's actually going to be an open dot. And so we turn the blue and the pink into an orange piecewise function. So f of x is considered this entire orange function. Now, just to make it look a little bit nicer, I'm going to get rid of my transition point dotted line, and that is what that piecewise function looks like. Okay. Now, there's another part on this assignment that talks about the absolute value function. So if we have y equals absolute value of x, or here, let's do that in functional notation. So let's say g of x is equal to the absolute value of x. If we graph that on a calculator, or if we know what it looks like a V, like that. The reason being, if we just did y equals x, we would have a line that looks like this. So this piece of the blue one and this of the yellow. But since it's absolute value and that forces everything to be positive, we flip this negative part up to being positive. And so that's why absolute value looks like that. Now, one way that you can envision this is it could be a piecewise function, because we have this piece that follows a certain pattern, and then we have the other piece that follows a different pattern. So the transition point is right at x equals 0, right there. So if we're trying to write this as a piecewise function, we're going to have something right here when x is greater than 0, and something right here when x is less than or equal to 0. Now, on this, we could actually put the equal to sign on either one of them, but we only want to do it on one. Now, if we're looking at the pink side, this is just going to follow y equals x. So if we're greater than 0, then y equals x. So all we have to do is write an x right there. Now, if we're on this green side, we actually have a negative slope, but it's a slope that's comparable to the positive slope. So it's just down 1, right 1, down 1, right 1. And so we follow negative x right there, and that takes care of that one. Okay. Now I'm going to do just one more example. So let's do h of x equals x plus 1, and then x is greater than or equal to 2, and then we'll say x plus 1 squared minus 6 when x is less than 2. Alright, now we could graph both of these by hand, but just to get the calculator into it, calculator froze, so let's reboot that. Okay, so let's pretend like you didn't know how to do this by hand. We would go here, we would try x plus 1, and then graph it. And we see it crosses at 1 on this. It has a slope of 1, 1, there. So this is our green function. Now, if we go back to that, we can graph the next one. So parenthesis, x plus 1 squared minus 6 and graph that. Okay, we see it dips down like that, and let's see, 1, 2, 3, 4, 5, 6. We can see this tells us we go down 6, left 1. So we go 1, 2, 3, 4, 5, 6, left 1. So that's where that is, and then we just draw our parabola. Okay, being super exact with your graphing is not really important for this. I just want to make sure you get the concept of it. Okay, so after we've graphed both of those, we don't need our calculator anymore. Now, I would suggest marking your transition point. So it's 2 and 2 for both of these. So we go to 2 on the x-axis, and I'm just going to draw a dotted line. Okay. Now, for this first one, the green function, we only graph it to the right, or like greater than or equal to 2. So only to the right of 2. So I'll take my eraser. Anything to the left of 2, I'm not going to draw. Get rid of it like that. And then the red function, similar thinking, everything to the left of red is okay, or on the red one to the left of our transition point is good, but we will get rid of everything else. Here, I'll just redraw that. I think that's easier. Okay, now we have to mark our transition points. So on the green function, we have an equal to sign. So we do a filled in dot, or a closed dot. And then on the red function, we don't have a line under it, and so we do an open dot. Okay, and then if we want to look at this as one function, so h of x, we can just color this in one color. You don't absolutely have to do this step, but I'm just doing it to illustrate that it is one function now, instead of two separate functions. It just has two pieces. Okay, if you need additional help, please come to Math Lab. Until then, calculator.